Hi everyone, and welcome to the video on section 2.8. In this section, we're going to really look deep into the connection between a function, its derivative, and its second derivatives. So, we're going to start off with this parabola that you see graphed here. So just a kind of basic quadratic, looks like it's shifted up a bit, right? And what we're looking at here is we're going to try to see if we can think about describing as much as we can about this picture without it usually having it. So what we're going to do, a lot of the problems you'll see, is I'll give you a table of values or a graph of the derivative. So you'll have information about the derivative, and we're going to see how much we can learn about this function just from that derivative information. So for this first one, I just wanted you to see this so you could kind of have this in the back of your head as we go, because it's easier the first few times you do this to already have the answer here. So a couple things that we're going to be talking about that we can just look here. So for this function f of x, we want to do things like, where is this going up? Where is this function increasing? Well, just looking at the picture, it looks like 0 here, x equals 0, is the min, the turning point. And so it looks like it's increasing from 0 to infinity. Okay. And that means it's going to be decreasing from negative infinity to 0. And then what about the concavity? Well, because this is opening up, this is concave up always. So just looking at the function, nothing else, grabbing those. Now, how can we get this from the derivative? Well, remember what the derivative does. It's telling us about the rate of change of this function, instantaneous rate of change, right? So we talked about this a little bit last time. If you are increasing, we made the connection that, well, that just meant that your slope of your tangent line was positive, right? Just to kind of help you remember that, here we go. Draw the tangent line, slope positive. Oh, my function's increasing there too, right? Okay, what about over here? Draw the tangent line. Oh, my slope is negative of this tangent line. Oh, I'm decreasing. So that's the connection. That's the connection we have to make. Okay, so now pretend we didn't have the picture. And let's look at this. So we've got x values, we've got y values of the function, and then we've got derivative values. This is going to be tough. I'm not gonna lie here. It is difficult when you start this off, going back and forth between f and f prime. The graphs of them, the tables of them, talking about them. It's hard to have multiple functions kind of in your head at once. So that's something you're going to have to practice on, being very clear about what function you are talking about when you are saying things. So, okay, we see that we go out to negative 5 here in the x. The function, the parabola, is at 27, and its derivative is at negative 10, which means it's decreasing, right? That's what that tells me. My function at the point, negative 5, 27, is going to be going down. Okay. And so we actually can read that. Look at this. All of these say decreasing. I'm decreasing. I'm decreasing. I'm decreasing, right? So what else can we get from this? Well, I'm decreasing for sure. At each of these x values, my function is going to be going down. But the rate of decrease, negative 10, that's pretty fast. And then negative 9, oh, that's not quite as fast. And then 8, 7, 6, 5, 4. So you're seeing not only from the derivative can you get just by its value that it's decreasing, but you can also get the idea of concavity from this, right? Because this is where things go crazy, but just follow me here. I've got f of x. Okay. Now, what was the connection? If f prime is negative, like these numbers, this is decreasing. Okay. So this is a rule that connects your function with your derivative. All right, so what else can we say about a connection between f and f prime? Well, let's look at f prime again over here. Right over here, we see that f prime is positive, right? 1, 2, 3, all positive numbers. Okay, what does that mean? That means that at these points, these x values, right, the function itself has a positive rate of change, instantaneous rate of change, which means it's increasing. So this is telling me that f of x is increasing. So let's think about what we're doing here. We are looking at f prime and seeing, based on it being negative or positive, that the original function is decreasing, increasing. And the rule becomes that your function is increasing whenever its derivative is bigger than 0, which hopefully doesn't, isn't too bad based on the way we define the derivative as being the limit of the rate of change. It's rate of change, so it should tell you how the function's changing. Okay, so that's another rule. Okay. And so you might be like, oh, good, look we've done all this stuff. But what about this point 0? Like, okay, what could be happening at 0 here, and where the derivative is also 0, just by coincidence? X is 0, the derivative is 0. Well, you were decreasing and then you were increasing. So what happened in between? Well, something that we can get out of this is that when your derivative is 0, like this, f prime is 0, those are your possible critical points. So what's a critical point? A critical point is just whenever a function is going to take that turn. So we go up here and look at this. We're decreasing, 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 and then we take a turn and go up. So this is a possible point where we could turn. I say possible because even though you get the derivative is 0, that doesn't mean necessarily that you've turned. If you look at a cubic, there are some cubics where it looks like you're about to turn and then you end up still increasing or decreasing. And so we're going to see that below in an example. But if you're looking for where we're turning, that's going to happen when the derivative is 0, because look, it's going to be negative to decrease, positive to increase, so boom, boom. All right, so that's a ton of information just from this, and it agrees here, right? Increasing, decreasing, concavity, we'll come back to that. So, okay, let's go back down. Now we have a cubic function. Okay, let's go through our list again and see what we can piece together. So, okay, where are we going to be increasing just from looking at this? Well, it looks like forever, right? It seems like I'm always increasing. So possibly forever? Maybe this point, it looks like we might have stopped here. So we'll put this for now. And we'll have to think about that. Decreasing, never. Okay, so nowhere. And then concavity, where are we concave up? Well, it looks like from 0 to the right, we'd be concave up. Okay, and then concave down, yep, it looks like we're concave down, bowl down, cup down, from negative infinity to 0. All right, so okay, we got this going. Let's see what this says. All right, so we've got x, the function, and its derivative. So let's see here. Derivative, positive, 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 all the way down, positive, positive, all positive except for right here is 0. So what does that tell me? F of x, notice I'm talking about f here, not f prime. This f of x is increasing because the derivative is positive, we have stopped here, right? 0 means we stop moving. And then here, we again have increasing. Okay, so awesome. That's exactly what we saw, right? So boom, you can read that off the derivative just right away. Snap of the fingers. Okay, so there is another thing here though, all right, and that's this idea of the concavity. So how do we figure that out, right? Like the concavity, what are we going to do there? And the way we actually do that is by exploring the second derivative. Okay, so the second derivative gives us concavity. All right, and so here's the way it works. I'm just gonna lay it out on there. If the second derivative of a function is positive, u are going to be, the function u is going to be concave up. If the second derivative is negative, the function is going to be concave down. Okay. So this might kind of seem like it's kind of coming out of nowhere maybe, right? Like, what do you mean in here? Well, first of all, let's just look at this function. And one way, if it helps, of thinking about this is the second derivative as acceleration. So just remember, we've got f of x is like position, f prime is like your speed, really velocity, and f double prime is your acceleration. Okay, so what does it mean to be concave up? Well, in this scenario when we're increasing, what's happening when we're concave up? Well, when we're increasing here and we're concave up, the increase, as we go right, the increase is faster. It's increasing faster, 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 faster. So if you think of this function as describing somehow your position, then what is this saying? This is saying that it's increasing all of these spots so that you're always going fat. You're always moving in the positive direction, right? Because I have a positive slope here. But what this is saying, because it's concave up here, is that okay, I'm moving in the positive direction, but kind of slow. Okay, over here I'm moving in the positive direction, but a little bit faster. Oh, I'm really picking up speed now. Oh, I'm getting a lot faster here. That's that acceleration concavity idea. So it looks like I'm concave up here, which means as I'm increasing, I'm increasing faster and faster and faster and faster. All right? That's the second derivative being 0. Now, you might look at this and be like, well, I still don't see where the second derivative comes into play. Why the second derivative? Like, maybe I kind of get the acceleration piece. And here's the big whammy that, is maybe going to make your head explode a little bit, but that's okay. It takes a while to get used to this. So here it is. Ready? Where's f prime coming into this? Okay. So, f to f prime. How'd I get there? Well, I saw f and I said, okay, take the first derivative. Right? That's what it is. F prime, I take the first derivative. Okay, how do I get from f prime to f double prime? Well, I just take the first derivative of f prime. So you might be like, well, there's already a prime here. It's not the first. But what I'm saying to do is f prime is a function, right? So just pretend like it's the first function again. How do I get to this function? I have to take one derivative. So all I'm trying to say here is that this f double prime is just telling me about the rate of change of f prime. Right? So this f double prime is just the rate of change of f prime. But then how does it connect back to f? Well, let's follow this little diagram. F to f prime is a derivative, first derivative, so I'm just rate of change. So f prime is the rate of change of f. This is telling me, though, f double prime is the rate of change of f prime. So then this connection is that f double prime must be the rate of change of the rate of change of f, which is the acceleration. How is your speed changing? That's acceleration, second derivative. And so hopefully you could see that with this picture. The concavity instructs me how my change is changing, how my speed is changing. However you want to think about it, it's fine. So concave up, if I'm increasing and I'm concave up, then my change, my increase that we saw is actually increasing. What about over here? Well, I was concave down. So if I'm concave down and my function's increasing, well, what's happening? Well, just kind of look at it, right? Draw some tangent lines for yourself. Well, that's a pretty big increase, right? From this tangent line, that's a pretty good sized slope. Now keep going right, and like, okay, we'll be here now. Oh, that's not really as fast anymore. And then we get here, oh, we're going slower now. We're still increasing, but we're slowing down. So being concave down and increasing, what's that telling you? It's telling you that your speed, your rate of change, is actually slowing down, right? It's decreasing. So my rate of change is decreasing. I'm still increasing as I walk to the right, which we always are saying, walk right, walk right. As I walk to the right here on this graph, my function's increasing. It's just because it's concave down, that increase is slowing. All right? And we could do that on here. Look. All the way at -3. You don't even see it on here. This is derivative. I'm moving fast. 27. I'm moving fast. Okay, go right a little bit more. Oh, I'm still moving pretty fast, but I'm slowing down a little bit. Okay, I'm moving fast still, but that increase is slowing and slowing and slowing and slowing and slowing and slowing. I'm concave down. That's it. Look at this. This is decreasing, thus f is concave down. My rate of change is increasing, so f is concave up. See how I keep always going back to f? That's the goal, is to learn about f, so we got to keep going back. Okay? I know this is weird, but these are super useful rules that you just want to try to get in your head and practice a ton. Right? And it's going to take a while to really make the connections back to these graphs. That's okay, you just got to practice. All right. So lots going in with this cubic function, right? But we can read a lot of it just kind of from this graph, from this table. Look how quick we can do a lot of this stuff. Here to here, I'm increasing. Okay. Here to, let's see, all decreasing, 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 decreasing until about here. This is all decrease. Okay, and then it switches to positive. All here, I'm going to be increasing. Just immediately. Positive, increase. Negative, decrease. Positive, increase. Done. Okay, great. I just immediately know kind of what's going on here. It's tough exactly to see where this happens from the table, right? I just jump negative, positive. It's a little hard to see where, but that's okay. You know, it's just a table. I'm not expecting you to be able to read this and be like, oh, yes, I figured out exactly where this switches. No, you just have to kind of try to get a feel for where things are happening. So I'm going to be increasing, then decreasing, then increasing again. All right, but guess what? I can read concavity from this too. Watch this. All right, watch this. So I'm increasing, okay, here, right? But watch what happens. My increasing, 18, I'm going fast. That's slowing and slowing and slowing and slowing and slowing. Okay, if my increase is slowing, what did that tell me? I'm concave down. CD for short. So I'm concave down there. Okay, but what's happening here? Okay, I flipped now, right, to decreasing, but I'm decreasing even faster and faster and faster and faster and faster, all the way through here. So this block here, I'm decreasing faster. And it might be kind of hard to keep all of these different things in your head. So here's the trick. All of these different scenarios, I'm increasing, concave down, I'm decreasing, concave up, all those scenarios. This is what you do. Ready? You look at this one, and you look at this one. Okay, maybe I should give you some more information than that. Let's cut this in half, and let's cut this one in half. Every scenario you could come across with the mix of I'm going up and concavity is right in here, right? So this little section is concave up and increasing. This section is concave up and decreasing, just this chunk. This chunk is concave down and decreasing. So in the viewpoint of this, we can always think through what's happening with a function in each of these scenarios. So, what's happening here? Here, we're increasing, but we're concave down. Here, we're decreasing, but the rate of decrease is increasing. So let's go over here, right? And if we're decreasing, we know we're decreasing, our function's going down. We're either right here or right here. Now, all you have to do is pick out, okay, I'm going down, and as I move right, I'm going down faster and faster and faster. So going down, but ooh, I'm slowing. So not that one, it's got to be this one. I'm going down, and that rate that I'm going down, the numbers are getting more and more negative because I'm actually going down faster and faster and faster. So this is also concave down then. Right? So this is also concave down. Then I hit this point 9, the fastest that I am moving down, right, at this point. And then it makes a switch. So here, I'm still decreasing, okay, but that rate of decrease is technically increasing because my number's getting bigger. But if you think about the magnitude, the speed of it is actually slowing. So I know that that's pretty tough because technically this is an increasing section. But if you think about it in terms of just speed, right, then I'm still decreasing, but in terms of going down, as I move down this table, I'm actually decreasing, but I'm not going down quite as fast. So that's going to put me, right, decreasing concave up now. So right here, that works for concave up. And then let's see here. I'm increasing now, and what's happening, I'm increasing faster and faster and faster and faster. And so that's concave up as well. Whoops. I will leave that in. So what do we have? We are concave down from what looks like -5 up to -2. And then, or because this function goes forever, we could say -infinity to -2. And then we're concave up on the other side of -2, of course not including either of these, forever. Okay, so let's see if that works out, right? We're concave up, what did we say? Concave up, -2 to infinity. -2 to infinity. Look at that, right here, bowl up. Sweet. I'm concave down, -infinity to -2. Look at this. I'm a bowl down to -2, and then that's where they switch. Didn't even need the graph. So I'm increasing, and I get past -4 into the -3s. So somewhere in here maybe, -3 point something. And if I look here, yeah, it was increasing, and look at that, in between 375 and 35, somewhere in there. So little hard to tell if this is 335, 375, who knows? But we can just say, I don't know, 3.6. It's hard to tell. This is really unsure, just from the table. Okay, but we're increasing, and then we're decreasing all the way through here until right about here, which looks like it happens just past -1. Okay, yep, so we're past -1 where we do that switch. Awesome. And then we go back to increasing. So we'll just color it, right? We are increasing. Let's throw some colors in here. We're going to be increasing will be green. So that's all of this is increasing up to about here. Then we're decreasing all the way down to about here. And then we're going to be increasing the rest of the way. Okay, then the decrease will happen everywhere else. Concavity split up differently, which is often the case. But again, all that came straight from the table. Just looking at this. All right, so what are the general rules? The general rules are if your derivative is greater than 0 on an interval, your function's increasing. If the derivative is less than 0 on an interval, your function's decreasing. Okay? And then what we get from that is we've got a good place to look for things like max mins. Where could that happen? Well, a max or min happens when you've hit a point where you've stopped increasing or decreasing. You've switched. So if I'm greater than 0 here, increase, less than 0, my function decreases, then in order to switch from one to the other, I would need this to be 0. Okay. Now, this max-min discussion, there's actually another way, right, where this could happen. This could happen when this is undefined. So this is just another little separate thing that you should always be thinking about, right? So if my function looks like this is not differentiable. We talked about this in the last video. Not differentiable here, so f prime doesn't exist at this point, but it's still a maximum, okay? And it's because I switch from my first derivative being a positive number to my first derivative being a negative number. That switch happens either here or when f prime of x is undefined. If you keep these two in the back of your head, you can always find absolute. So you could find both absolute and local max and mins, which is cool. Okay, so then what's the next step? The second derivative of f, if that's greater than 0, then you're concave up. If f double prime is less than 0, you're concave down. And what's the thing that comes here? What's this place you switch concavity? That's called an inflection point. So this middle piece is where you can get an inflection point. So you've got these tools now to find max mins, find turning points, find inflection points, right? Boom, boom, boom. You've got these now where it's just an equation you solve. That's powerful. Here's a function. You don't have a graph. You don't have a table, whatever. You need to find a possible max or min. How do you do that? Set the derivative equal to 0, solve. There you go. Where's the derivative undefined? Solve. There you go. I want to know the inflection point. Second derivative equal to 0, solve. Boom. Super powerful. Very, very important idea. All right. So let's try another example. So it says assume the turning points of the function graphed below are at x equals -1. So that's just here. X equals -1. X equals 5. And there's a point of inflection at x equals 2. Okay. Sketch the graph of the derivative function on the blank. So this is maybe sounds very scary, but it's not too bad. We just got to think about this. We have to go connection. F of x to f prime. Okay, ready? If f of x is increasing, with a little table here, just to remind ourselves, then the derivative is positive. If f of x is decreasing, then the derivative had to have been decreasing, then the derivative had to have been negative. So watch what I get to do. Ready? I get to look at this function and be like, okay, it's decreasing. So we'll write this out over here. F of x is decreasing where? negative infinity all the way until negative 1. Guess what that tells me? That tells me this is where f prime will be a negative number. So I know when I go to draw f prime, this tells me that my f prime is negative in this range. So I know when I start drawing that picture, I better have this f prime be below the x-axis for all these values. Okay, if this is increasing, then where's it increasing? It's increasing from negative 1 all the way up to 5. What does that tell me? That tells me, right, that my derivative is positive on these values. So I better make sure when I draw this function for these x values, my derivative stays above the x-axis. Okay, what's happening here now? Well, actually, what happens again is this starts decreasing from 5 to infinity. So I better make sure that when I draw this function from 5 to infinity, I end up having my derivative, the graph of the derivative, be below the x-axis. Okay, so I'm going to draw little points at negative 1 and 5 because they're super important for me. Negative 1 and 5. Those are my big important points currently. Okay, and so you could do a lot of different things here to help you draw this. Like so many different things. You can draw little things like this. Negative 1 to 5. I'm going to put a little plus sign here because I know my function should be up here, somewhere up here. I'm going to do a little negative and a little negative here because I know my function should be down here, okay? Like, it's almost like these points can kind of break your function into pieces. So I can't just draw anything I want here and here and here, right? I've got to do a little more work. Well, what's the more work I have to do? Well, I know that something about the values of the function being either positive or negative, f prime. But now what I need to do is connect the concavity, right, to my derivative. So again, remember, this is tough. That's okay. We're going to figure it out. So I guess I could do that. That's nice, right? So, okay, if this is concave up, what does that tell me about this function? Well, remember, concave up was the same thing as f double prime being what? Positive. Okay, but wait, remember, the second derivative is the rate of change of this. So if the rate of change of this function is positive, that means this has to be increasing. What about this one? Concave down. Well, that's this being negative, which means, remember, a negative value derivative means I'm decreasing. Okay, so this function is concave up from negative infinity to 2. So watch. F of x is concave up where? Negative infinity to 2, which tells me that the derivative, right, is increasing there. So the derivative is increasing wherever the function is concave up. So from negative infinity to 2, I need to be drawing an increasing function. So let me put in the 2 here. So watch, this isn't going to be a nice picture, but it doesn't matter. I have to draw a function that is below the x-axis up until negative 1, okay, where it's going to cross. So here I go. Okay, then what happens? As soon as I hit negative 1, right when I go past it, I'm going to be positive. Okay, I can keep doing that. But then, remember, when I hit 2, I need to switch from increasing now to decreasing. So here, boop, there's 2. Okay, and then what's going to happen? Well, we got to figure it out. What happens after 2? Well, f of x is concave down from where? 2 to infinity. Okay, that tells me f prime is decreasing there. So as soon as I hit 2, I've got to switch my f prime now to decreasing. And then, oh, remember, as soon as I get past 5, I got to be down here. So, and then I'm going to decrease forever. Again, not great pictures, right? But hopefully you can kind of start to see the shape here. And even though it's very poorly drawn, this is actually going to be a quadratic, a parabola, upside down parabola. Right? And that's something we'll learn how to figure out from the actual function itself in terms of the formula. We'll learn some tricks in a few sections. This is going to be a parabola. It's the worst parabola you've ever seen drawn in your whole life, but it is a parabola. Right? It's negative up until here. It hits a top point here, and then it starts decreasing, and then boom, goes negative again. And that's all of this. Remember, this is f prime. All of that. How did I get all that information? Just by looking at f. When it's going up, when it's going down, when it's concave up, when it's concave down. There you go. So this is tough. This is a lot of work, a lot of going back and forth between functions, but it's definitely doable. Okay, now we're going to go the other way. This is f prime. Let's try to graph f. So we got to think about our connections, right? Remember, f prime greater than 0. What does that tell me? F is increasing. F prime less than 0. F is decreasing. Okay, so then let's just look at this. This is the derivative. Don't forget, this, we're starting with f prime. All right, I'm positive from here to here. Here to here. I'm a positive number. I'm negative, so I'm positive here. I'm negative here, just the y value, I mean. Negative here. Then I hit this point, and I turn to positive again. So what did I actually just do? I just figured out where f is decreasing, f is going to be increasing, f is going to be decreasing, and f is going to be increasing. Okay? So what I can do on this plot is, for convenience, let's just call this negative 5.5, even though it's clearly not. So negative 5.5, negative 4, and we'll just call this 0.5. So negative 5.5, right? Negative 5.5, negative 4. Oops, that's the wrong one. Oops. So negative 5.5, negative 4, and then it looks like 0.5. Okay, so what do we know about f again? It's going to be decreasing over here. It's going to be increasing in this little range, and then it's going to be decreasing in this range, and then it's going to be increasing over here. So however I draw this function, I know that in these little ranges here, I know what's going to happen. Okay. Well, what else? Well, I need the concavity too. I need some more. Well, how does the concavity work? Remember? Okay. If f prime is increasing, right, that's f double prime is greater than 0, which is f is concave up. If f prime is decreasing, then that means the second derivative is less than 0, which means f is concave down. Okay, so it looks like this function, f prime, is increasing from negative infinity up to here. What about here? This point. Okay, so we'll call that negative 4.8. Why not? So let's say that again. F prime is increasing from negative infinity to about negative 4.8, which means that f is concave up in that same little area. Okay, now f prime is decreasing until here. which is called negative 1.2. So f prime is decreasing from negative 4.8 to negative 1.2, which means that's exactly where f is going to be concave down. Okay, then I'm increasing again forever. So I'm also increasing from negative 1.2 to infinity. Right? As soon as I turn this corner, I'm increasing. Okay, so let's try to see if we can figure this out. Okay, so we know our function's decreasing, right, in this area. So let's just start up here and we're just going to start decreasing. But we also know that we're going to be concave up. So I'm going to be concave up, decreasing, right? Okay, I'm concave up, decreasing. What's the next thing that's going to happen to me? Well, I switch over being concave up to concave down at negative 4.8, which is about right here. But before that, I actually am going to be concave down, increasing. Or sorry, concave up, increasing. So watch what happens. I'm concave up, but I'm decreasing. I hit this point. Now I'm still concave up because remember the concave up switches here. This is where that concavity switches from up to down. So, okay, I'm hit this point. Now I'm supposed to be increasing, but still concave up. Okay, now I'm going to be increasing, but oops, concave down. And then I hit this point, and now I'm going to be decreasing. And I'm going to be concave down until negative 1.2, which we'll call about here. So here I go, I'm decreasing, concave down. I hit this, and I'm supposed to now switch to concave up. So I'm going to be concave up, I'm concave up, I'm concave up, and I hit this point now, and now I'm supposed to start increasing and concave up. And there we go. So there's my function. Not the nicest function you've ever seen, but, you know, not too terrible. Okay, so a lot of work. These are tough. A lot of back and forth. F prime, F double prime. What are you talking about? Concavity, increase, well, all this stuff. Just take your time, work through it yourself, label pictures, be careful, go back to these rules, but you can definitely do it. All right, so any questions, let me know, and I'll see you in the next video.